Hello, everyone. So, my name is Caesar, and I work as a software consultant, helping Ruby on Rails teams ship code faster and of much higher quality. And today, I want to talk to you about two of my favorite languages. One of them is Elixir, and the other one is Elm. So just a quick survey done by Stack Overflow by dev type. So for backend developers, these are some of the most popular languages. And as you can see, JavaScript is on top. And for front-end developers, you can kind of see the same thing. But my point is that none of these languages that I'm going to talk about today are in these charts. So, why am I talking about these two? I'm basically a Ruby developer. I've been coding Ruby for the past decade. And in today's world, most web apps are either in Python, Ruby, JavaScript, and mostly languages that are object-oriented and are very usable. It's easy to start, easy to do something. And then there are other types of languages like Haskell and OCaml, and mostly functional languages that are focused on maintenance and making maintainable code, making it easy to refactor code. And so I think these two, Elm and Elixir, are somewhere in the middle, meaning that it's easy to start and it's also easy to maintain them. Here's a quote by Joe Armstrong, which is the author of Erlang, talking about OOP. The thing is, with OOP, you've got all the state that you need to keep in your head. And so you kind of need to reason about that, and that makes it difficult to build software. So, to me, I think the solution is functional programming, and both of these languages are functional. Here's what functional programming gives you. It makes concurrency possible because you have no deadlocks and no race conditions. It makes testing very easy because all you have is basically data in and data out, and that's all you need to test. You don't need mocks that much. Makes it easy to debug code because there's no global state. All you need to take into account is what your function receives and what your function gets out. And so all this makes your code much easier to understand and to work with. So another thing is functional programming tries to avoid shared states, so two functions will not access the same state. It favors immutability, which means you don't need to track the history of your values. And it also tries to avoid side effects, meaning that your functions will only care about the value that they receive and the value that they spit out, so they don't affect state that's outside of that function. And it's also declarative, which means you tell it what you want to do and not how to do it. And if you need another reason, I think this is enough to start looking into functional programming. Okay, so let's start with Elixir and see what's cool about it. Like I said, it's a functional programming language. It was built by one of the Rails core members. If there are Ruby people here, maybe you know José Valim. He's got a few libraries that are very popular in the Rails community. And it's a dynamically typed language, but it's got some type specs like TypeScript, if you know TypeScript. And it's a new language for the Erlang VM. It's got a Ruby-like syntax, so if you've ever coded in Ruby, Elixir is really easy to pick up. And there's also a Rails-like framework called Phoenix. And like I said, it's a language for the Erlang VM, which is battle tested for the past 30 years. And Erlang is not only a language, is a platform. So you've got the language, you've got the virtual machine, a framework for message passing, and a few tools to help you. It was built by Ericsson to solve the problem of communicating between telecom switches. It kind of runs for a long time, and it was tested a lot. And the main goal was to scale really easy and to have fault tolerance, but we'll talk about that. So it's got a OTP framework that does all that. And it's highly available. So they advertise 9 nines of availability, which means it goes down 31 milliseconds per year. And so they also say that people could actually die if it goes down, because if your phone goes down, then that's pretty much you're screwed. And so Erlang is really good at concurrency because it's got cheap process switching. And also distribution. So if you add more machines, it will know how to run your code on all those machines without you doing anything. Fault tolerance is one of the core values that it advertises, which means your app can recover very easily without bringing the whole system down. And it can scale horizontally, so you can just add hardware without changing your code, and it just works. Here's at a high level how the VM looks like. So for each one of your CPUs, basically there's a scheduler that can manage all those tiny processes that Erlang creates. And now let's compare this to a typical web server. So we're all used to the following requirements. So you need a HTTP server. That's usually Nginx or Apache. You need something to process your request. And in my world, there's Ruby on Rails, but there are other languages and frameworks. You need something to process your long-running requests, so you don't block the user's browser. And then you need some kind of state. You keep your state somewhere, so you might use Redis or something in memory. And then you want to persist your data, probably in a database like Mongo or Postgres. And then you want to run your jobs at certain times of the day. You might use cron or other programs like that. And if something goes down, you want to start it back up, so you need services to do that as well. And so that's the typical environment you see today, and here's how Erlang does it. So you've got everything baked in. Okay, so to the code. Here's how you define a function in Elixir. You've got the def keyword. Like I said, it looks like Ruby. Then the name of the function, and then between the do and end, you've got the body of the function. Here's how you call a function. You've got the namespace, which is the string in this case. It's a module. Then the name of the function, and then the function arguments. And this is an anonymous function. You've got the fn keyword, then the function arguments, then that arrow, and then the body of the function. And this is how you define a module. You've got the def module keyword, then the name of the module, and then the body of the module where you put your functions. Am I going too fast? It's okay? Okay, so two concepts from functional programming. One is pattern matching. And in Elixir, this is done with the equals operator. This is not assignment, it's actually pattern matching. So the stuff on the right is compared to the stuff on the left. And all those variables that are not bound to any values will be bound. So in this case, value here will be bound to the number 2. And there are a few cool things you can do with this. Okay. You could have multiple functions with the same name, but different arguments, and whichever matches your argument will be run. So if you call hello with Joe, you'll get hey Joe. If you call it with Jim, you'll get hey Jim, because that's what it's matching. In Elixir, functions are first class, so they're basically values. You can assign them to variables. You have function composition, so you can take small functions and create bigger ones. You've also got higher order functions. So here we've got a map function that takes a list of numbers and then an anonymous function. And for each element in the list, it applies that function. And also the add here is assigned a anonymous function that takes an argument and returns another function. So you can call that by creating a new function that takes the rest of the arguments. Okay. You've got also pure functions, which means that if you pass the same argument to a function, it will always return the same value. So in this case, inc is a pure function because if you send it the same argument, it will always return the same value. And decrement is a impure function because no matter how many times you send it the same argument, it will always return a different value. And you've got referential transparency, which means you can replace the definition of a function with its value. So what's interesting for developers? The first thing, if you've worked with other languages like Ruby or JavaScript, you've noticed it's very hard to test. And Elixir gives you that. It gives you easy testing. You've got data in and you've got data out, and that's what you're testing. Your code quality will improve because, one, you're using functions a lot, and two, you've got compile time checks and some cool tools for testing. One of them is Elixir will check the documentation of your method. So if you have some example code, that's actually a test, and it will run it. And syntax is similar to Ruby. So if you're coming from a Ruby background, it's easy to start. And I think the most important thing here is it teaches you a new way of thinking if you're coming from OO. Reasons to use it is if you want to use the Erlang ecosystem and all its tools with a nicer syntax. If you need highly distributed systems to work on all your CPUs and all your machines and all of their CPUs. Low latency, so it's got soft real time. And high reliability, so your system will be almost guaranteed to be up. When not to choose Elixir. If you need speed, Elixir is not your best friend. The ecosystem is incomparable to Ruby or JavaScript. The number of repositories is kind of low. It's not designed for parallelism. It's designed for fault tolerance and high availability. And then there's the learning curve, which means you need to learn functional programming. You need to learn its ODP system. You need to learn about the virtual machine and its web framework. So there's a lot to take in, but I think it's worth it. If you've got a business and are thinking about using Elixir, there are a few reasons. First one is it never goes down, almost never. It's very responsive, so your users will always see something. Even if you have bugs and crashes in your system, they'll always see something. It never crashes because it isolates your crashes into processes. So if a process goes down, it's restarted, but the rest of the system, it's continuing to be up. And it's got lower maintenance and growth costs because the code is higher quality, it's easier to test, and it's got less regression bugs. And that's about Elixir. And now let's switch to the front end and look at Elm. So Elm is also a functional programming language. It's built entirely for the front end with the goal of building web applications. It's reactive by design, so if you've ever used React and Redux, it's very similar, but with the difference that it's functional and a few others. So it's basically JavaScript, but with no runtime exceptions. So if it compiles, it works. And it's also got some enforced semantic versioning, so you'll never get a breaking API change. Here's how it works. Basically, you have a model, which is the state of your application. And that's rendered through a view function into the user's browser. So the state goes to the browser, and that's what the user sees. And whenever he performs an action, it will get sent to the update function, and you get a new model. So that cycle repeats over and over. And so that's kind of the Elm architecture. So let's talk about the language. Like Elixir, it's got immutable values, which means you don't care about the history changes. It's got strong static types, and I think this is really cool because it allows the compiler to find a lot of errors for you. You don't have to test as much. It's got type inference, which means the compiler knows a lot about your code. So you get a lot of tools out of the box for your editor and all sorts of code checks. Also, type annotations serve as documentation and makes debugging very easy. Like Elixir, it's got pattern matching, which makes it easier to extract data out of data structures. And one cool thing about the tools is you've got automatic code formatting. So you've got one style, and your entire team uses the same style. It's got a very nice debugger. You can scroll through history and copy paste the entire state of your application. You can share it with others, and that's really cool. And pure functions, which are very easy to reuse and compose into bigger functions. And here are some of the stats for Elm's popularity, which are very recent. As you can see, Elm is tiny compared to JavaScript, for example. It's got a very, very small community, but it's growing slowly. Here is some Elm code. On the left, you've got the values, and on the right of the column, you've got the type. So you see some numbers here, strings, characters, multi-line strings, a list of strings, a list of numbers. It's got records, which look like JavaScript objects. This is a custom type, so you can declare your own types. In this case, you've got a type that has 2 possible values. You can alias types, so here is a record that's aliased as a point. And these are functions. The square function takes 1 argument, which is n in this case. It's before the equals. And after the equals, you've got the body of the function. And sum does the same thing. It's got 2 arguments. And after the equals, you've got the body of the function. Here are 2 functions. On top, you've got the type declaration. So this one here. It says this function receives an int and returns a bool. So that's guaranteed. You always receive n as an int, and you always receive a bool out. Then the next function is odd, also receives an int and returns a bool, and it composes the is-even function. So this one here is composed with a not function, and they're applied to the argument. And you can write the same thing This one, you can write it without providing the argument, as in point-free style. Okay, so if you want to see this app, you can go to the URL on the screen. But I've extracted the code here. So this is a minimal Elm app where you declare your state as the model. In this case, it's a string. And you need a message. So you declare a type of message that has the value clicked button. This is what the user can do in your app. And then you've got the update function that kind of changes your state. So the update function receives one of those messages that you declare here. In this case, it receives click button. And when it receives that click button, it returns a new version of the state. So because the state is just a string, it only returns a string. And here's how you render that state in the browser. So you've got a view function that gets the model, which is a string, and returns HTML. And so div is a function that has two arguments. So two lists. The first list is empty. In this case, you will put attributes in there, so like class, ID. And then you've got another function here for button and another one for a div. This button has an attribute of onClick. So when the user clicks that button, the clicked button message will be sent to the update function. And so the cycle continues, and basically that's your Elm app. So that's all I had to say. And one last thing is that you can try these languages, see if you like them, extract what you like about them out and use them in your apps. And maybe you'll use them both. I don't know. It's up to you to try that. Thank you.